Hello, my name is Jorge Isaac. In this video, I will explain how we designed, simulated, and tested a 4-bit adder using VHDL and the DA10 Lite FPGA board. So the first file is the VHD code for the 4-bit full adder. This circuit has two 4-bit inputs called X and Y, one input carry called CI, a 4-bit sum output called S, and a final carry output called CO. So the design uses 4 single-bit full adders connected in series. Each stage takes 1 bit from X and Y, along with a carry input, and produces a sum and a carry output for the next stage. So let's go to the VHD. So the second file is test bench, which is used to simulate the circuit before programming the FPGA. The test bench doesn't use a real hardware. Instead, it creates signals that act as input to the adder and monitors the outputs. How we test the circuit? In this test bench, we use 3 nested loops. The first loop changes the value of X from 0 to 15. The second loop changes the value of Y from 0 to 15, and the third loop alternates at the carry in, say CI between 0 and 1. This means the simulation automatically tests all 212 possible input combinations, ensuring the adder works perfectly in every case. So let's go to the Intel Questa starter to see the waveform. So next, we run the simulation in Questa FPGA. The waveform shows the inputs X and Y and CI changing along with the sum output S and the carryout CO. For example, if X equals 9 and Y equals 6 with CI 0, the output S is 15 and CO 0. So you can see here, say CY is 0, the output would be 15. If CI is equals to 1 is added to the same numbers, the result becomes 0, 0, 0 with CO equals to 1, showing an overflow. So the simulation confirms that the logic is correct before we move to the hardware testing. So let's go to the plane planner and implementation to the FPGA. After the simulation, we set up the pin assignments in Quartus Prime Lite to connect the FPGA inputs and outputs to the physical switches and LEDs on the DA10 Lite board. So switch 1 to switch 8 are used for the 2 4-bit inputs X and Y. You can see, let's change this 8. Switch 9 is used for the carry in, say in. let's 0 to let's 3, sorry, the 4-bit sum output S, and the let 4 shows the final carryout CO. So let's go to compile the FPGA and see you in the FPGA. Also, for compilate the FPGA, we click on programmer and then start and wait until the code is uploaded. So see you in the FPGA board. So here we are on the FPGA board. So once programmed, we can use the switches to set values for X. These are the X, and these are the Y's. And the CN is this switch, which is switch 8. So here X equals 9 and Y equals 6, with CI equals to 0. So the let's show 15. So here you can see 15. So if I flip the carry in switch C in, the output changes to 0, 0, 0, and the carry outlet turns on. So this demonstrates that the adder works perfectly in real time. So we can change to other values, for example 1 plus 1 equals to 2, 1 plus 3 equals to 4, and 1 plus 7 equals to 8. So you can see this works perfectly.